How's everybody doing? Good? Good. Okay, let's get started. Any questions? I think what we're gonna do is practice a little bit 7.3, just a few problems, and then I'm gonna jump in and introduce the rules to 7.4 as well. We're starting to run a little bit out of time, trying to cram everything into one semester that should be in two. Any questions though before we start working? Cool. Any particular problems we're having a hard time with? Or we didn't exactly see how to solve? And if not, then that's totally fine. Let's look at 7.3.3 then, and figure out exactly what we want to do. Does anybody have any idea what problems we did last time? I know we did some of them, right? Do you remember your numbers? No? Okay, that's fine. Let's look at the last several. Let's do like 31 through 35 maybe? 7.3.3. Samantha, how about you've got 31? Ashley, 32. Wait, 1, 2, 3, 4, 5. I don't think Jillian will be here. That's why we'll just do 34. So 31, 32, 33, 34. And then Dennis, do you want to try one? No? Okay, that's fine. Okay, so 31, 32, 33, 34. Yeah, does anybody have those done already? Okay, that's fine. Yeah, let's just work on them for a minute. Work on those for a minute and then put them up on the board one by one, and then we'll get into 7.4.
What was the section again?
7.3.3. all still working, or you done? Done? Let's give it one more minute. We'll all get finished up so we could all watch each other do this. You guys watched the video I uploaded the other day, or I mean, I don't care if you did, but I uploaded that video explaining 7.3's rules, I believe, right? Okay, cool. Yeah. So hopefully we can use this well. Does anybody need a refresher on 7.3's rules? Or are we doing okay with these problems? You're kind of... Well, let's see what we get. Alright, you can even come up and do it now. Let's get it done. Okay, so 7.3.3, number 33, right?
Yes.
Walk us through this problem.
The 33. So we have not A and G. We have not A and E. Then we have G or D. We're supposed to finish with not A and F. So, instantly, there's some more stuff that we can do with both of these, and that's some of it we're going to be able to work with them. So we get not A or not G of 1. We get not A or no, or not E from 2 to Morgan. And so we have this G or E right there, so I want to try to get to that somehow. And so what I see is that we have a not A for both of these, so there might be something that we can do with distribution right there.
Okay, nice, yeah.
So we get not A or not G, so we're going to combine these two so that we can kind of factor out the not A. So now we can take that not A out. And then we get not A for not G and not E.
Nice, good.
And so then it's going to be just 6 dist.
Good.
Then we can do a De Morgan's rule on that one. Just 7. And so since we have the negation of this due to the double negation rule, do I need to rewrite double negation? Or?
No.
Okay. So because that, then we can get the not A by itself using 8.3 disjunctive syllogism.
Good.
I'm going to write it over here because that's too low. Writing it. So then we can do not A or anything, but we need to get this F, so we can do not F.
Good, good, good.
Using 9 in addition. And then we can get to the conclusion using De Morgan's rule.
Yeah, there you go. Perfect.
Yep. 10. Oh, write it D correctly. 2 more done.
Beautiful. Okay, yeah, that was really good. Does anybody have questions on that one?
I just have a question between like the 8 and 9. Can you just like write out the double negation again? Like,
Yeah, if you're going to write out the double negation for 8 and 9, so it would go like this, right? The 9 would be, well, 3, you'd go 3 double negation, not G or E.
oh, okay.
Yeah, and then it'd be negating this side, right?
Got it.
But you don't have to do that if you don't want. The book likes you to, be OCD about every little step, but I won't make you be. Any other questions on that one? Okay, excellent. Let's go next. As before you go, I know I mentioned in that video if you watched it, how De Morgan's is like a useful tool that you could do weird things with. Did everybody understand that? Like mechanically how to use De Morgan's? Because it's something that's actually kind of important to memorize. Like how would I De Morgan's this? I don't have any negations. So how would I use a De Morgan's on that? Yeah, so think about, let's say I take my standard case in the book, and I have this, not A or E. If you think about it in terms of meaning, De Morgan's is obvious why it works. But it's also helpful to be able to come up with sort of like a memorization mechanical, step-by-step process for doing it. Because you can get really complicated stuff and still De Morgan's it, even when it doesn't have negations on it. And if you ever do logic for anything more than just this class, it's really helpful. Because I can take, what I do here is I get rid of the negation on the outside. How do I get rid of it?
To do not A and not B. Is that what you
Yeah,
mean?
so there's a couple ways of thinking about what it means to get rid of. Because remember, we're not thinking in terms of the shapes or like a math class where I don't want us to be comfortable with talking about like just adding or removing negations as if that's like a visual thing we're doing, right? Because we're talking about the meanings of structures of propositions. And obviously are propositions material objects? No, not really, right? We utter them, we say them, but let's just say the grass is green. That's in your head, right? That's in your head, now it's clearly not a physical thing. So you can't manipulate it like a physical thing, right? But that's what we're doing here symbolically. So what De Morgan's is telling you is that negations of and negations of or. So and can be defined as a negation of an or can be defined as a negation of an and I explained this in the video. But how you can think of it mechanically is you're adding a negation to everything. So you add a negation to the outside. You add negation to the inside parts. And then you flip the or to an and. Well, what's the negation become here? Nothing, right? It's the same as just a positive. So you could just kind of take that away. And I just did that mechanically with the De Morgan's, right? And that's what it becomes. So what if I don't have a negation? Well, I add a negation to the outside, I add it to the parts, and then I flip the symbol, right? So I can do De Morgan's on more things than just like ands and ors with negations inside or outside. Does that make sense? The book does not show you how to do that. But it's something that I found one of the most useful things that I found. Does that make any sense? So with De Morgan's, add negation to outside is step 1. Add negation to inside parts is step 2. And then flip operator, right? So what if I had A or not E? How can I De Morgan's that?
It would be not, then inside the parentheses, not A and E.
Good. And not E if you want to think of it that way, or just E, right? Good. Does that make sense? Now, in terms of meaning exactly how that's working, you just have to look at 100 examples and put them in truth tables to learn. I mean, this is technically an algorithm, right? A step-by-step process for changing an and to an or. But if you follow these rules, just trust me, this is how you change ands to ors. If you follow this algorithm, you'll always do it correctly. Does that make sense? Okay. Just a little note. Because, like, basically, out of all these rules we just learned, the only ones I ever use are De Morgan's and double negation. Out of all of these, you really barely use any of them in real life, other than, conjunction, simplification. You can put all these other rules and basically just reduce them to, like, modus ponens, modus tollens, hypothetical syllogism, conjunction, De Morgan's, distribution, double negation, and then you're pretty much done, right? Like, you could just get rid of all these rules and have like 6 of them. And if you're good at De Morgan's, it makes it even easier. Okay, who wants to go next? Yeah, come on up. Oops, I just erased all my rules. Modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism. There you go.
Okay, so the first thing I did was simplify this.
Good.
And then, because I had a not S, I did most terms, not S and R.
Good.
And then I did De Morgan's.
Good, good.
And then I simplified this again. I did not or. And then I added some 23. And then because I had this, I got this.
Good.
And I did the ones
Good. This is great.
and then I got not G, but F.
Good.
And then I added the S and the not G.
Good. That's great. Perfect. That was awesome. Yeah, great. Look at that. Fast 14-line proof. I'm proud of this class. Any questions on this one? Okay, cool. Who's next? We are getting so much faster at proofs, it's insane. I know it's a dry class. There's not much exciting to talk about. But it's exciting to me to see us be able to do this stuff. Good. Yeah. Yeah, CD. That's perfect. Yeah, good job seeing that with those big conditionals. Okay, yeah, they get it to line up. Yeah, the book wants you to do that type of thing. So you're absolutely correct. Good. Yeah, that's fast. Dang, good job. Yeah, seeing this conditional right here and being able to see, oh, I should link these and then do a constructive dilemma with them. And thinking 4 steps ahead. That's good. I like that. Beautiful. Ready?
I mean, I have the answer, but that's just because you happen to randomly assign me one that had the answer on it.
That's okay. Let's walk through it and try to see what we can do. Let's see where we were getting stuck.
This one is 16 lines, so I may take that.
Nice, 16 lines. Okay, so with the other rules we've had, you'll notice that with things like modus ponens, modus tollens, I described this in the video as well. Modus ponens and modus tollens doesn't go both ways, right? So when you have P then Q, P therefore Q, you're deriving Q from those two premises, P then Q, P. You can't reconstruct that by having Q, right? But with something like distribution, if you look at how the book defines it, the rule, you can go either you start with 1 and get 3, or you start with 3 and get 1. The rule sets in 7.3 and 7.4, again, are equivalences in meaning. So if you have one, you have the other. They're the exact same thing. Does that make sense? But whereas like modus ponens, hypothetical syllogism, those you can only infer one way, exactly from those premises to your inference. Just to make sure we're clear on that.
It takes a very, like you were saying earlier, very, like, surefire, the long way around route.
Yeah. Yeah, look at all these distributions it's doing. Oh my god.
It works though, man.
Yeah, it's just a pain.
There are a few steps that probably works fine.
When on 10, when you say 2, is that 2.4 or 2.9? Modus ponens.
Didn't write it down now. Should be 2. Hold on. Yeah, 2.
2.9? Okay, I'm just making sure. Oh yeah, I see it now.
Okay. Yeah, 'cause I know I've written it down wrong before in the past. So that's what's tripping me up.
This one's torturous with how many distributions and commutativities you have to do.
It gave me the answer which is probably a good thing, because at first I didn't really see it, but after staring at this for like 5 minutes, I eventually got what they were doing.
Okay. Yeah. Yeah, no, sorry, I give you the hardest one. I mean, I struggle with distribution and commutativity still. And this one was just like all distribution and commutativity.
I think it's just the distribution of De Morgan's that are the hardest for me.
The De Morgan's.
Distribution of De Morgan's.
Follow that algorithm. Add a negation on the outside, add negation to the parts on the inside, flip the symbol. And then don't worry about it. Yeah. Any questions on this hellish one? I hate this one. And in real life, I pretty much never have had to use distribution of commutativity. All right, okay, so let's do, how much time, what time is it? Does anybody have time?
11:01.
11:01, okay, we got plenty of time. Let me introduce the 7.4 rules. We don't have to practice with them today unless we want to. And then, did anybody by any chance, like, revise or bring in a new argument that you can use? Okay, I want to take a look at that too. And kind of work on that. But let me go over these next 4 rules real quick. Okay, 7.4. We've got more rules of replacement. We've got transposition, material implication, equivalence, exportation, and tautology. Okay, let me start with, I'll go easy to hard. We'll start with tautology. I'll get the form right. Okay, this one should be obvious. If I have square, what's it mean? Square is true, right? So I can conclude from square, because I know this will always be true, right? If this is true, it's at least one. And I can also say square and square, because I'm just repeating myself. It doesn't actually change anything, right? Everybody see this one? Okay, stupid baby rule. Any questions on tautology? All right. The use of tautology is that there are some proofs where we'll be able to see the solution, but we'll be like, how do I know it's true because it just repeats itself, but I only have one part. Don't I need to match the form? So tautology is literally just to get you a matching form. If this was your conclusion, and in the premises you got this, you'd see that you already had your conclusion, right? Does that make sense? In the content, not in the form. But this book wants us to match form, and technically, symbolically, we need to match form, not just content, if that makes sense. So that's the point of tautology. What about, what's the next easiest one? Material equivalence. And this one says, P if and only if Q is the same exact thing as P implies Q and Q implies P. Why is that the case? How does this make sense?
They're each necessary and sufficient for each other.
They're each necessary and sufficient for each other. So when you have P triple bar Q, what it's saying is P is sufficient for Q and Q is sufficient for P. Well, P is also necessary for Q and Q is necessary for P. Well, that's just the same thing as saying this, right? P is sufficient for Q, Q is sufficient for P. Q is necessary for P, P is necessary for Q. Yeah, so they're saying the same things. And this is why I don't like the triple bar. I like the double arrow. Because it just becomes obvious, it's just an arrow going both ways, right? Does that make sense? Okay. What's the other one? It lets you derive this, which you could do without this rule if you have De Morgan's distribution commutativity. But it also wants you to know that this is valid as well. Okay, so if I have P if and only if Q, that's the same thing as saying I have P and Q, or I don't have either of them. Why does that one make sense?
You can't have one and not the other.
You can't have one and not the other. So let's say I start with the assumption, I'll just say 1. I have P if and only if Q, right? Well, let's just assume that I don't have P. If I don't have P, what happens?
You don't have to.
I don't have Q, right? So if I don't have P, then I won't have Q. So that's one possibility. Let's just say I'm joining these together. One possibility of this is whenever I don't have P, I don't have Q. Okay, what happens if I have P? Well, then I have Q, right? Well, there's only two possibilities. P is true or P is false, right? So it's either going to be P or not P. Okay, 1. P if only if Q. Can't I break this down into two conditionals? Right? Now I combine it with this is just an obvious truth, right? Not law of non-contradiction. It's just, there's only two truth values to something, true or false. Okay, so if these are the two options, well then, that's always true. So I can say from this it follows that Q or not Q. I kind of join those together, right? And then through commutativity, through distribution, long story short, I can eventually get to this. And through De Morgan's. But, just for understanding, does anybody not see why this is true? Do I need to put it in English? I feel like at this point, English statements put in here are more confusing than looking at the symbols. But does anybody want an example in English? You good? Okay, so one more time. P if only if Q is the same thing as just splitting it up and saying P implies Q, Q implies P, all that, right? P if and only if Q is also equivalent to P and Q, or not P and not Q. And the reason for that is just because, look, the two possibilities are I have this or I don't. I have this or I don't. So the two possibilities are I have this, in which case I have this, so I have both of them, or I don't have this, in which case I don't have this, so I don't have both of them together, right? Make sense? Okay, so there's material equivalence. Here's the hardest one to understand in my brain historically, why this happened. I don't really get it. But I know it did happen, and I know it spawned a whole new branch of logic. But this is material implication, or just implication, is the definition of what the arrow or the horseshoe means, what an if-then statement means in our language. And it just says, P implies Q is absolutely logically equivalent to not P or Q. Do you remember how I told you at the start of the class that the arrow, like the material implication, it doesn't actually have to do with any like necessary bond or relationship between P and Q? It just means right now it is true that if I had a P, I would also have a Q. That Q is a necessary part of P. But it could have been a different way. Maybe it'll be different in the future. I'm saying right now, when P is true, Q is true. When Q is not true, P is not true. Now the only way this is false is how? How is this false? If P is true and Q is false. Because it's a counterexample. I disproved it, right? Well, if that's the only way it's false, then what this is essentially saying is, oh man, how do I put this? Not P or Q is saying, in order for this to be true, you can't have this combination. This is true, this is false. But it would work if you had not P and if you had Q, right? It would also work if you had not P and you didn't have Q. It would still be true technically. It would also work if you had P and you had Q, right? All three of these combinations fulfill this, don't they? Right? Because let's just say P is false. Well, then not P is true. P is true, so that's false. Q is true here, so that fulfills the condition, true. Q is false here, so this fulfills the condition, right? Because you still have at least one. Q is true here, and so you still at least have one, so that fulfills the condition. Now, how is this false? You don't have even one, right? So it would mean I don't have Q, and I don't have not P. If I don't have not P, what's that mean? I do have P. So the only way this is false is when I have P and not Q. Or, let's put it this way. P is true, and Q is false. They're the same exact truth conditions, right? Does that make sense? So, what this reveals is that in this type of logic, material implication isn't really what we think of as implication or like a relationship between P and Q, that P causes Q or P will necessarily guarantee Q. Literally all the arrow means is that one of these has to be true, maybe both. In other words, I can't have in this world right now, in the actual circumstances, I can't have P and not Q, right? What happens if I De Morgan's this? If I do a De Morgan's on this, what's the procedure I just described? Remember? Add negation to the outside, then to the insides, and flip it. Not P and not Q, which is just the same as saying, yeah, it's not the case that P and not Q. Right? So this is literally just defining what this means. And it should be obvious to you that, well, then we need a new symbol, or we're not going to be able to express thoughts like P causes Q, or P guarantees Q, where guarantee is something about, right, with necessity. Not just logical circumstances, but necessity, right? Does that make sense how if I say, if it's a cat, then it's a mammal? That's not necessarily expressed by this. That's a strong claim about the nature of a cat. It's impossible for a cat to not be a mammal. So we need some other type of conditional to express those sorts of claims. And that would come within modal logic, which is an advanced sort of logic that comes after this class. Does that make sense? Okay, but for our purposes, just remember that these are equivalent because they have the exact same truth conditions. Again, the truth conditions of this thing, if this was true, it would have to be the case that this was false. And so we would have and then the only way it's false is when this is true, and that this is true, and this is true. Okay, good. Yeah. So if you look at this and you do truth tables, you'll see they're exactly equivalent in terms of their truth conditions. Okay. Questions? It is hard to teach what material implication means at the start of a class because students always catch on that the arrow or the horseshoe is being weird. It's like weird and not intuitive. But then without being able to show you these rules and teach you truth tables first, it's hard to describe exactly what's going on. Okay, what's the next easiest one? Transposition. Okay. P implies Q is the same exact thing as not Q implies not P. Why? Can anyone explain it to me? Why are these two things the same?
Could it be because of like modus tollens?
Yeah, because of modus tollens, or the relationship between the necessary and sufficient conditions, right, that modus tollens pulls from. So how would we be describing that these are equivalent if we're using the necessary and sufficient conditions talk? So think about with modus tollens, right? P then Q, not Q, so not P. The way to explain that, without just pointing to examples, is, well, this says that P is sufficient for Q, and Q is necessary for P. So if I have not Q, I haven't met the necessary condition for P, which means I can't have P, right? So there's the explanation of modus tollens. Well, this is kind of like hypothetical version of modus tollens, where it's saying, look, if I failed to meet the necessary condition for P, then I wouldn't have P, right? So wouldn't that mean that not Q is sufficient for not P? If you fail to meet the necessary condition, then you fail this part, you don't have P. Meaning not Q is sufficient for not P. Right? Does that make sense? And again, you could put these all in a truth table and say that they have the exact same equivalent values. Okay, last one, exportation. P and Q then R is the same exact thing as P then Q then R. This one always trips me up. On critical thinking test number 2, I accidentally had a student come up and say, wait, isn't the answer to this problem wrong? And I looked at it, I was like, oh yeah, that is wrong. I should give you credit for that. And I gave the whole class credit. And then I realized, oh wait, no, I was right. I was using the exportation rule correctly, but the student wasn't. But then I'm so bad at exportation that when the student told me I was using it wrong, I just assumed I was wrong and gave the whole class credit for that problem. Cool. So exportation's like simple in meaning when you unpack it, but there's something about exportation, distribution, commutativity that they just don't work with my mind. Okay, exportation says, if I have both P and Q, then I have R. So P and Q are sufficient for R. R is necessary for P and Q, right? That's the same thing as saying, if I had P, then if I also had Q, then I'd have R. Let me repeat that slowly. This says, if I have P and I have Q, then I have R. This says, if I have P, then if I also have Q, then I'll get R. You see how those are the same? Here's an example in English. This one normally helps. Let's say if I get gas and a new tire, then I will go to the store. How exciting. Another boring example. Okay, so this is a translation of this. If I get gas and a new tire, then I'll drive to the store. This one would be, if I get gas, then if I also get a tire, then I will Go-to store. If I said these in English, would you think I was saying something different? If I get gas and a new tire, then I'm going to go to the store. If I get gas, then if I also get a tire, then I'm going to go to the store. Those are the same things, right? So there's your English example of how these structurally are equivalent. Any questions? Okay. I think we're all doing pretty good on these rules, so I'm not too worried. Let me see how much time we have left in terms of the syllabus before our next test comes up. So I think the next test unlocks, is it Thursday? I think it is. And again, man, if this would load, come on. School's Wi-Fi has been crappy today. Okay, yeah, Thursday the next test is already unlocking. We just took test number 3. And the reason why they're back to back is just because they're really one test split into 2 parts, so you can earn the maximum number of points. So test 3 was over these first 8 rules. Test 4 is going to be over everything, right? So you got 100 points just for knowing these. You'll get another 100 if you know the whole thing. And it'll be fairly short. I think test 3, we turned that in today, most of us. Like, it was pretty short, right? How long did it take you, on average?
Like 9 questions.
Yeah, 9 questions. How long time-wise do you think it took each of you?
Like 30, 40 minutes.
30, 40 minutes. About. Yeah, okay. Yeah. Cool. So it'll probably be about the same length. It'll just be problems incorporating all of the rules. So that unlocks Thursday, and I think you have a week to do it. Yeah, you have until the 26th, so a little more than a week, 12 days. I'm not too worried about what I'm seeing in this course in terms of the class average is on all the tests have been an 80-something so far. So that's a very good sign. But yeah, since it is coming up, I've got to pack all this content in and start wrapping it up so we can learn 2 new proof techniques, which are starting Thursday. And then I'll cover those real quick, and then we've got to start on October 26th, we've got to start predicate logic translations, which is a whole new system of logic that builds upon the basics of this, but it's a whole new language, and it's pretty complicated. So we're moving pretty quick at this point. Does anybody have concerns that we need to slow down or anything? Are we okay? Okay, I'm just checking. And again, for anybody that's watching the recording, email me. Any questions on these rules, 7.4? Let's look at your argument and see. You brought one, right?
Yeah.
And see what we came up with. All right, what's your argument about? Describe this argument to us.
My argument is about whether or not Jesus Christ is the Son of God, given if we accept him as a moral example. So it's kind of a variation of like the Lewis trilemma.
Cool.
And so I was able to, to me it seems like it has to be valid, yet I haven't been able to like prove it.
Mm-hmm.
So we'll see.
Yeah, let's take a look.
Okay, so my first premise is that if Jesus Christ, which I'll abbreviate as JC, exists, then JC is either insane, or I guess these should be was. existed
Cool.
was either insane, a liar, or the Son of God. Two, if JC was a liar, JC is not a moral example. If JC was insane, JC is not a moral example. Four, if JC is a moral example, JC exists. Then my conclusion is if JC is a moral example, then JC is the Son of God.
Okay, cool. So, yeah, I see the logic of your argument. So basically, you're saying that, kind of following Lewis, a little bit different, that, look, there's three options we have. If the Jesus Christ of the Gospels really existed and those Gospels are describing him correctly, then he's either lying, grifting people, or he's just a madman, or, you know, he actually was correct, in which case then he would be the Son of God, right? But in common culture, people who don't necessarily believe that Jesus was the Son of God also treat him as like a good teacher, a moral exemplar. So you're using that logic against them because you're saying, well, if he's a liar, then clearly he's not a moral exemplar. He's not someone we should be modeling our lives and behavior after because he's, you know, founding an entire world religion based on a lie. That's two. If three, if he was insane, well, that shouldn't be a moral exemplar either, right? We should not model our moral character after insane people. So three, and this is, or four, that was three, this is four. Now if Jesus Christ is a moral exemplar, then Jesus Christ exists. I'm not sure if that's going to have any function here. I'm also not sure if it's true. Because you can have moral exemplars that don't exist, like fictional characters, right? Like Gandalf is a great example of a moral exemplar in Lord of the Rings. Gandalf is a great guy. You want to be like Gandalf in certain respects, but Gandalf doesn't really exist, right? So I'm not sure if 4 is true, but I'm also not sure if 4 needs to be true for this argument to work. So your conclusion is ultimately that, look, if you want to say he's a moral exemplar, then the only option left to you is Son of God, because the other two options don't work, right? And that's a purely hypothetical conclusion, right? It's not saying he is a moral exemplar. It's not saying he does exist. It's not saying that he is the Son of God. It's if you want to keep saying that he's a good teacher and a moral role model for us, then you have to admit that he would be the Son of God, right? Make sense, argument-wise? Now let's symbolize it. And you can erase whatever you need to on the right-hand side if you need room. Let's symbolize it and see if we can prove it.
Okay, so
So if he existed E, then
and he's either insane, or a liar, or the Son of God.
okay. I'm wondering if we need to make that exclusive. I don't think we do. We'll see. But clearly implied there is that these are 3 mutually exclusive options, right? I don't think we need to do that. That's a stronger claim, but we'll see.
Example 3 is example 4 is
Okay, so 1 if Christ exists, then one of those three things are true. 2, L, if he's a liar though, then not a moral exemplar. If he is, what's F there?
Where?
In 3.
Oh, that's supposed to be an I.
Oh, okay, yeah.
My handwriting just
If
got-
he's insane, then he's not a moral exemplar. 4, if he's a moral exemplar, then he exists. Therefore, if he's a moral exemplar, then he must just be the Son of God. Okay, so as written, you could prove this to be valid with the technique we're going to start learning Thursday, which is called conditional proof, which you make an assumption. Now let's just say that the assumption is that he exists. Then you're going to have one of these three options, right? So if you would write down here, and I'll teach you this starting Thursday. 5, you'll say assumption for conditional proof. He exists. Then you draw this out. Then you get, you start playing around with these conditions, and you end up with a bunch of hypothetical syllogisms maybe from that assumption. But as it is right now with our rules, yeah, you can't really prove that's valid yet. Unless, am I missing something? Does anybody see how you prove that that's valid? Here's my suggestion. 4. Well, maybe you could prove it. Write 5 and do a hypothetical syllogism on 1 and 4. Now on 2 and 3, do the material implication rules. So you go not L or not M, yeah, and not I or not M. And now if you join both of those together, do you see where I'm going with that?
Yeah, are
Kind
you
of.
gonna try to factor out the N?
And leave and isolate that to one side, and maybe turn it back into something. Do another hypothetical syllogism.
Ooh.
Yeah.
Yeah, I should have done that. I was able to get to here, and then I factored the M out, and I just didn't know where to go from there. But I think that's right. Let's see. So not
I think that's right.
yeah.
Yeah, you're already better at distribution than me. I hate that rule, like I said. Yeah, there you go, exactly. So not M will give you not L and not I. So then if you did 5, oh wait. Not L will give you not M will give you not L and not I. So
Hold on. I think I might. If we do transposition, no, that won't work, will it?
you could see though with 5 and 10. 5 says if M, then one of those three options. But 10 says if M, then two of those options are not going to work, right? So, in a sense, we don't have a rule for it, but you can see a disjunctive syllogism there. You can kind of start seeing that 11, even though you don't have a rule, it would be M implies that S is the only option left. Does it make sense? Yeah, we just don't have a good rule. I don't see how we could get that, but with our rules, but it makes sense. So I think that would be valid. Yeah, you just have to explain to somebody that that's there. So yeah, good valid argument. The weakness I think will be here in the, again, 4. I don't think that's true. I also don't think you need it. So it's not going to be a critical criticism. Then 1. Does anybody see anything wrong with 1? Like conceptually, maybe. What if Christ exists, but he's not as the Gospels portray him?
Yeah.
Then those categories don't apply. Maybe he's just some dude that said some stuff about holiness and about reformation of the current first century Jewish religion, but he didn't make any claims like this. And so he wouldn't even be insane, right? So 1, I think, could be modified to say, if Jesus Christ existed as the Gospels portray him. Now in 4, I think you could replace it with Jesus Christ did exist as the Gospels portrayed him. Then you would get, well, there's 3 options with most opponents. And then you would say, well, these 3 options, these are what they lead to. Then you affirm on 5, a new premise, he is a moral exemplar. And then you conclude, because he's a moral exemplar, then this stuff. Does it make sense? Yeah, so then it would be a straightforward argument for the conclusion, Jesus Christ is the Son of God. Now you could figure out different hypothetical ways to get this hypothetical conclusion back. But I think it's got the bones of an argument that's going to work. Does that make sense? Yeah, okay, good, yeah, that was good. I'm glad to see that we're able to do this. What time is it? Till 11:38. So not much time. Does anybody have anything else they want to share, an argument? Okay, next class, we probably won't have time to do another argument like this. Would somebody, at least one person, be able to bring another argument, try to think of one for next Tuesday to share? We'll just share like one a day. Does anybody want to volunteer to do it? Should I pick? What if I made it a small extra credit assignment? Would you then volunteer to do it? Okay. How about this? I'll send out an email saying this. If you bring me in over the next few weeks, if you each bring me in 3 arguments that you've worked on over the next few weeks, we'll cover like one a class on Tuesdays like this. I'll give like 15 points extra credit, 5 for each argument. And we'll just turn them in after those 3 weeks. I'll send out an email explaining why today, but sound good? Does that make it worth it to do extra work? Okay. Okay, I don't have anything else to cover. Are there any questions on anything we've covered? Okay, again, the next test unlocks Thursday. You have 12 days to do it. Treat these tests like homework. Don't freak out about them. They're very short, and it's just like the homework. And 70% of the test is like fill in the blank, right? You only have to do a few proofs. Any other questions, comments, anything? All right, I will see you all later. Take it easy.